Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is good stones and it is of a medium level. So the problem says that geek is in a geek land. So basically we have been given an array of integers and each index the value denotes the amount that the person can move from that index. For example, positive 2 denotes that the person can move 2 indexes to the right. So from here you can go to 1, 2 to this particular index. Minus 1 denotes that you can move 1 index to the left. So this keeps on going on. Any positive integer means you can move to the right that number of steps. Any negative integer means you can move to the left that number of steps, right? So basically sometimes this particular configuration can form a loop and we have to avoid that loops. Every stone that is a part of the loop are not good stones, and all the stones that are not part of a loop are called the good stones, right? So we have to just return the number of good stones in this particular array. So for example, in this particular test case, let me just, for example, these are the integers 2, 3, minus 1, 2, minus 2, 4 and 1. So from 2 they are going to 1, 2 spaces to the right. From this particular minus 1 they are going 1 space to the left. From this particular 3 they are going 3 spaces to the right, which is here. And from this minus 2 they are going 2 spaces to the left. So if you see that we have formed a loop from 2 then here like this is the loop, right? And this keeps on going on. This will continue from minus 1, this will continue indefinitely, right? So we have to avoid these kinds of stones. So, and from here you can go to positive 2, that is you can go here, and from here you can go to plus 1, that is here. That is out of the range, right? And from here you also go to out of the range. So basically these three are the good stones because they are not part of any loop. These three are the good stones, right? Now we have to find the number of good stones in the river or in the array, right? This is our question. Now this question is similar to finding loops in a directed graph. So we will be using the same analogy. So what we essentially do is, right? For example, we maintain a visited array. I'll explain you a more intuitive approach and then how we can improve it later. Right. So the first intuitive approach is to have an array of not good stones or an array of good stones. For example, this is an array of not good stones, right? If a stone is not good, it will be marked as 1. If a stone is good, it will be marked as 0, right? So this is not good, this is good, right? So this is a Boolean array. Similarly, we will have to maintain a visited array. If it is visited, it will be marked as 1. If it is not visited, it will be marked as 0, right? So the idea is we start from a good stone, right? For example, initially this must have been a good stone as well because we have not discovered that it is not a good stone. So initially we assume that all the stones are good. So we start from a good stone, we mark it as visited, we go to all the indexes it directs us to. For example, it says we have to go to plus 2 position. So we go to minus 1, then 3, and then minus 2, and then again to minus 1. Once we realize that we are at some stone which we have already visited, we know that we are already in a loop. So what we have to do is we have to update all the indexes. For example, in this particular series, we visited index. Let me just write down the index. So this is 0, 1, 2, 3, 4, 5 and 6. So in this particular series, we visited 0, we visited 2, and then we visited 1, and then we visited 4. Right. So these 4 indexes should be not good. So I update them in my not good array. So 0 is not good. Then 2 is not good. Then 1 is not good. And then 0, 1, 2, 4 is not good. Right. So I update them in my not good array. And then I clear my visited array. Again, I have to clear my visited array. It's all zeros. Then I look for the next good element or the next good stone. Then I keep on traversing. The next good stone that I'll find is this one. I'll start again my search from this particular stone and then try to find a loop. If I don't find a loop, then there are no good stones in this series. Again, I re-initialize my visited array, right? So this is a pretty valid approach, but the problem with this approach is it will take a lot of time, just because we have to re-initialize the visited array every time we are doing this operation, right? Because once we find a loop, we are updating the not good array, but at the same time, for a new series, we have to re-initialize the visited array, which will take a lot of time, right? So what we'll instead do is we will maintain a variable or maintain a kind of flag. So for example, my flag is loop found. I've used this flag whether a loop has been found or not till now. It can have the values 1 or 0. So if a loop is found, I will not change the values of the visited array. I will not update the I will not reset the values of the visited array. But if a loop is not found, what I'll do is I'll reset all the values that I have updated recently in the current series. If you have done finding loops in a directed graph, you must be getting what I'm trying to say. For example, if I start from 2, right? From 2, I mark it as visited. So index 3 is visited. Then I go to index 5. Then index 5 is also visited. But at the end, I just get out of the loop and I don't find any loop. So my loop found variable would be 0. So what I'll do is, while I'm returning from the stack or the recursive call, I'll mark them all as 0. Right? I'll reset their values. So what is happening essentially is I'm doing the work of the not good array as well as the visited array with a single array now. Previously, I was maintaining a not good array separately and a visited array separately. But the visited array now is doing the work of both of the arrays. Right. So essentially, I'll go through it once more. What we essentially have to do is we just have to maintain. Let me just write them here. 2, 3, -1. I start my loop from here, right? I go to here, I mark it as visited. This is visited, this is visited. Then I mark this as visited, then I mark this as visited. And when I go to -1 back again, I see that this is already visited. So I have found a loop. I'll trigger my loop found variable that my loop has been found, right? And I'll just return from here. So I'll not update these values. Again, I'll reinitialize my loop found variable with 0. I'll start with 2. I'll mark this as visited. Then I go to +2. I'll mark this as visited. In the next step, I'll be out of the range, right? So what I do is when I just go back to my recursive call or my stack, whatever you're comfortable with, I see that my loop found variable is 0. So I have to reset these values, right? And then I go to the next not visited element, that is this one. So when I go to 4, I mark it as visited. I go out of the loop. I have not found any loop. I go out of the array. I have not found any loop. When I come back, I reset it as 0. Then I go to the next non-visited element. I mark it as 1. I go out of the array. My loop found variable is 0. When I come back, I mark it as 0. Right. So at the end, all of the elements which are visited will be marked as 1, and all the elements which are not part of any loop or which are good stones will be marked as 0. So I just have to count the number of zeros at the end, right? So this will be the solution for this particular problem. And if you guys know about how to find loops in a directed graph, I highly suggest you to study that problem first. That is a very standard problem. If you guys know that particular problem, this will be very easier for you to understand. So let me just show you the code now. I've initialized my loop found variable at the top. So this is a global variable, and this code will also be available in the description. So after the explanation, you can check that out also. So what I initially do is I've initialized my visited vector with all false or all zeros. I go through the loop, and for every element that is not visited, I just reinitialize my loop found variable with 0, that I have not found any loop. 0 means false, right? And I start my DFS. So in my DFS, I just mark my current node as visited. Then I try to find the child. Then the child will be equal to node plus the value at the current node, the value in the array at the current node or at the current index, right? So we just have to add both of them, and we have to just check for once that if the child should not be out of range. If it is out of range, then definitely we have like finished our DFS and we just need to trace back from here, right? So if I have visited the child, if the child exists within the index range and I've already visited the child, what I'll do is I'll mark my flag or my loop found variable as true, right? Because now I am entering the loop, right? As I've already visited that particular element. Else, otherwise, what I'll do is I'll just continue my DFS and array try. So there can be two possibilities. Either I get out of the array or I find a loop, right? So I just recall my DFS function to for those one of the possibilities. Now, after all of this is completed, after I'm returning, before returning from the function, what I do is I just check whether a loop has been found in the current series or not. If a loop has not been found, if you see carefully, this is a not sign. If a loop has not been found, I just mark my visited of current node as false because I have not found a loop in this current series. If I would have found a loop in my current series, I would have not updated or I would have not resetted this particular value, right? So this is what we are doing here. And after all the things are completed, at the end I initialize my answer as 0 and I just count the number of zeros in my visited array, and after it I can return my answer. So let me just show you the approach which I was talking about also. So I have made some wrong submissions as well, some TLEs. I'll show you why those were TLEs. So initially what I was doing is, this is what I was explaining to you earlier. I'm maintaining two separate arrays, right? I'm maintaining two separate vectors. The first one is the not good vector and the second one is visited vector. If you see carefully, I'm reinitializing every time this visited vector, which was giving me time limit exceeded, right? And every time a loop is found, if you see, this is the part where I'm finding a loop. I'm copying the values of the visited array to the not good array, or rather I'm just ORing the both of them to get the better result, right? It is essentially the same thing. What I'm doing is it is essentially the same in both of the cases, the current code and this particular previous code as well. It's just that I'm reinitializing my visited array every time and I'm trying to copy all those values, right? Now what I've done is I've maintained a flag, and if a loop has not been found, I'm just updating the values in the same array that these all are not visited, right? So you need to be careful of which approach you choose. If the test cases were smaller, then the previous approach would have also worked, but this is always a better approach, and this is the approach that we generally use while finding directed loops in a directed graph. So I hope you guys were able to understand the solution. I tried to give you a brief idea of like what are the different approaches you can go for this particular problem. And I hope this video was useful. If it was, you can subscribe to this channel. So till the next video drops, keep coding, stay safe. Bye bye.